Factor out the GCF from the polynomial. 4 parenthesis y plus 11 close parenthesis minus x parenthesis y plus 11 close parenthesis. Okay, what we're being asked to do is to perform factoring on this polynomial. Factoring in general, to factor something, to satisfy the instruction factor, we're expected to reach a goal ultimately of at least 2 factors times each other. We're looking to take what we're being given, which is in this case 4 times y plus 11 minus x times y plus 11, and convert this into a pure multiplication expression, meaning right now we're kind of looking at one kind of broad term of a polynomial being connected to another. What connects terms in polynomials are pluses and minuses, addition and subtraction. So you're looking at, in general, you're looking at 2 terms connected with subtraction. What glues a term together, like it's kind of the way I explain it to my students, is multiplication's like the glue that holds a term together. We have a factor of 4 glued together with a factor of y plus 11 in this first big term. In the second term in this polynomial, we have a factor of x glued to a factor of y plus 11 with multiply. Multiply is the glue that holds a term together. But what holds terms together, these 2 terms, is this subtraction. Okay, well now let's talk about what a greatest common factor is. A greatest common factor, a GCF, a greatest common factor. That's what GCF, that's what they're referring to in the instruction. A GCF is a greatest common factor of all the terms in a polynomial. Well, we generally find a GCF by working these letters backwards, from F to C to G. First, I look at the factors, then across all the terms. Then we look at what factors might be in common, the greatest number of times that a factor in common might appear, more than once. That's the G part of GCF. Okay, well, let's assemble what the GCF is. And I'm going to head back to red, and I'm going to say, well, the greatest common factor, if we looked at assembling what this is, we want to see first that these terms are already factored, because everything that we're seeing here is our individual, a constant times a parenthetical expression and a variable times a parenthetical expression. I can just start comparing. Let's start comparing what factors we have in common. Is there a 4 or even a multiple, like 4 could be broken out into 2 times 2. Are there any 2's, factors of 2's, or a giant 4 altogether in the other term? We have factors of 2, and we have a factor of y plus 11. Do we have a factor of 2's over here in this other term? No, not 2's. But what we do see is there's a factor of y plus 11 is involved in multiply, so we call it a factor. And there's a factor of y plus 11. There's an identical term. Identical factor in both terms. For every match between the factors in one term and that same factor in the other term, we would include one of those factors as included in the greatest common factor. We found one. We found a match. We found a factor that was in common between both terms. Now let's hop over to the second term. Do we see any factors of x in the first term, no. There's no x's appear here as factors of in the factors in this first term. So we don't include x in the GCF. Now, GCFs can be positive or negative. GCFs can always be positive or negative. So here's like the first step. First of all, to factor out the GCF, we needed to find the GCF. So the first step in factoring out the GCF would be find the GCF. And we found what the GCF is. It's positive or negative y plus 11. Okay, I'm going to write a clean copy of our given polynomial. We have 4 times y plus 11 minus x times y plus 11. And then to factor out the GCF, because that's our step 2, is to factor out the GCF. That's what's actually going to accomplish factoring for us, is something times something, is when we factor out the GCF. I'm going to write an empty set of parentheses for what remains. After we factor out the GCF, some polynomial is going to remain in here from the original. We have 2 terms. Look, we have 2 terms in here. I need to fill in 2 blanks, one for each term, after we take out the GCF. So here's the way I explain it to my students, is the GCF here, we're going to write it outside, y plus 11. This y plus 11 is going to distribute to each of these 2 terms. It's like I'm kind of doing distributive property in reverse. What would I need to put in these 2 blanks to get back to these original terms that are written right above each blank? So one thing to make sure of is that this first term of the remaining polynomial, we want to make sure it's positive, so that this GCF times whatever ends up being in this blank makes all of this come back. And I noticed this 4 is positive. So this, what I'm about to say here, determines whether we should use the positive or negative version of our GCF. Well, if we needed something times positive to make positive come back, we would have to choose the positive version. We're going to choose the positive version of our GCF, so that positive times positive makes positive. Okay, now let me show this. If we already have y plus 11 as a GCF distributing to something that's got to go in here, don't we already have this y plus 11 in the GCF? What factor is missing that belongs in this blank to make y plus 11 times something make y plus 11 times 4? It's the times 4. It's the 4 part. That's what's going to be needed to fill in this blank. Now, if we check everything, positive times positive makes positive. Y plus 11 times 4 makes y plus 11 times 4. That's what we needed in this blank, a positive 4. Okay, now what would we need to put in this blank? I'm just going to show over here. What would we need in this blank? Well, to put in there so that the GCF times whatever we need in this blank to make negative, or the opposite of x, times y plus 11 come back right above it. Well, positive times, I need a negative here, positive times negative makes negative. The GCF itself is this factor. What's the factor that's missing in this blank? The factor is x. So let's check this. Positive times negative makes negative. Y plus 11 times x. What does that get us? Y plus 11 times x. Now, by doing this, we factored out the GCF, and if we clean it all up, what we should have is 2 things times each other. Look, something for this blank, y plus 11, and something for this other blank, which I'm going to go back to green, because really the remaining polynomial is made up of 4 minus x. So do we have an answer that correlates to this response. Let's see. We have a y plus 11. When I'm looking at these answer choices, I see two answers that have y plus 11, here and here. These two answer choices do not have y plus 11, and I feel confident in our answers, so it can't be A or D. This is a testing strategy. If I was working on an exam, I'd eliminate answers that I'm not confident in. Okay, now let's look for the other factor. The other factor should be 4 minus x. And do we have an answer between B and C that's 4 minus x? Well, this one's 4 plus x, and that's not what we got for our second factor, so I'm going to eliminate B. And sure enough, here's the other factor of 4 minus x. The correct response to this question is C. It has both of the factors, one of which is the GCF, and that's what we were asked to factor out. And the goal of factoring has been satisfied because we took something that was generally a subtraction statement, and we turned it into multiply. So we've satisfied all the goals of this problem, and we selected C as the correct response.